covered 2 weeks before. So I told you, right, we have to create this chart to understand whether our data is in the correlation, positive correlation or negative correlation or no correlation, right? Kate also asked the question, okay, how it should validate. For example, I'm taking a project, okay, for example, I want to understand whether I have a correlation between my charge and the payment. Okay, if you try to plot this in the scale, okay, for example, if my charges are increasing, my payment is increasing. That is called your positive correlation. Okay, if my charges are increasing, my payments is decreasing, it's not going to happen. If just hypothetically think in that way, that is called your negative correlation. See, for example, if that's a negative correlation where your X is increasing, your Y is started dropping. Okay, that is one. And no correlation. There's no relationship between your X value and the Y value. That is your no correlation method. Okay, this easily you can put it in the scattered diagram and you can identify the correlation analysis. The same way, the P value will give you the detail about your correlation. Okay, whether the correlation is there or not. The correlation coefficient, this is a formula. Based on that, you can calculate. So I have one example to show you.
Sir, I have one doubt. Positive correlation, negative correlation is fine, but no correlation means like how it works. I mean,
that's why I prepared my Excel sheet. Okay, okay. So now I am taking two projects here. Okay. Okay. One is CRL, other one is Dr. A. Okay, you compare your correlation method. Okay, see, for example, I'm entering a charge and then I'm collecting this much. Okay, I'm trying to. Okay, I'll share. Okay, can you see my Excel?
Yes, sir.
Okay, see, I'm taking two different projects to explain you the correlation. Okay, one is CRL, other one is Dr. A, right? See here, what I'm saying is I'm taking the charge versus payment for this particular project. Okay, I'll take this particular point. Okay, which is the first one, charge. If my charge is high, right? It's the highest charge what I have, but you compare my payment. See, this charge impact I'm getting only in the month of 4th month, right? If you see here, 2nd month, my charges are low, but my payment is not reduced that much. Okay, it's in the flow, right? There is no relationship between these two parameters. Okay, if you see here, see your trend line for your charges. Okay, charges are going ups and down, right? When you compare the same thing for your payment, see here, your payment is flow is normal. Okay, your charges are dropping down, but payment is going in the normal flow. That means there is no correlation between these 2 points. Okay, we will do the same thing for other projects. See here, when your charges are increasing, your payment is increasing, right? And there is a flow is there. See, for example, if you compare here, see your flow, when the charges are increasing, your payment is slightly, it is increasing, right? From your start point to end point. Okay, that is called your correlation. I'm not saying that is perfectly correlated because of some glitches here and there, right? Say sometime what happened, we would have been posted or not posted the charges on that particular month, and then we would have been posted. These are all the few challenges, but compared to this chart and this chart, which is correlated, either CRL or Dr. A?
Dr. A is correlated.
Dr. A more correlated compared to CRL. So that's the reason when you're trying to create your GCR metrics, what we are trying to do is we won't take month on month, right? We will take 3 months average to try to map with your payment. But Dr. A, what we are doing here is when you're calculating the GCR expected, we will take only the 1 month or maximum 2 months we are take based on the AR days. Okay, that's the difference between this. See, sometime what happens is you cannot compare it in this order, right? See, sometime I am not able to understand. See, for Dr. A, whether this correlation is happening or not happening. Okay, so I'm not sure, right? Here it is going up, here it is not increasing. I'm not able to see that visibly. See, what we'll do, we will go for a linear regression methodology. In that linear regression methodology, we will identify whether it is correlated or not correlated. So how will you identify? We will check the p-value. Okay, if the p-value is lesser than 0.05, then it is good correlation between the data. Otherwise, we will not do this method. Okay, there's a p-value plays a major role here. Okay, that we will try to cover. Right, so this is the direction. Okay, the indirect is somewhat, for example, you take some other scenario. Okay, for example, we are plotting the two different people. Okay, who is taking a medication and then the fever temperature. Okay, if you take the medication, the temperature may fall down. This is the example for your negative correlations. Right, any question here? So actually the correlation is very, very important to identify whether your Y is dependent on the X or not. Okay, that's what I try to explain to you in the CRL. Okay, your in the CRL or any lab project or any of your project which is taking more than 90 days, your charge is not directly impacting your payment, right? So 3 months charges only impacting your payment, not the single month charges. Okay, that's a difference. If the same thing, if you come back to your ABA process, okay, what is happening here? When you file the claim, it will get paid within that particular 13 to 14 days, right? Or within a month, it's getting paid. The same thing we can talk about MMTX, right? MMTX, whatever you're billing it, we are able to collect within 18 days. So that is a direct impact. Okay, if you bill 100K this month, you know how much you're going to collect. If you're billing 1 million, you know how much you're going to collect. That is a direct impact. Some projects will be directly impacted. Some project may not be directly impacted. Everything you can define based on the correlation methodology. See, actually what the general process is, every month you have to check the correlation. Then you have to do your GCR analysis. Since we are not able to do that way, and that's what we are getting a bias. Okay, that bias will be the challenge when you're calculating this kind of reports. That's what we are accepting the error on it. Okay, I'm moving to next one. Okay, the causation and the statistical significance. Okay, the same thing what we discussed in the variable inputs. Okay, the same thing, causation. X, which is our input variable, and causation is a asymmetrical. Causation is not reversible, and causation can be difficult to determine. Okay, for example, if you go to Dr. A, the causation is difficult to determine, right? It's a very small, narrow difference is coming, and the correlation can help the where it is causation. See, for example, if you start putting into this particular parameter, then we can understand. See, for example, I'll take this particular scenario where it is a positive correlation. Okay, see, if you try to plot it in the Excel sheet, and then if you, for example, I have a positive correlation, the exact positive correlation between this team. If you try to put it for MMTX or your ABA client, it will be a positive correlation. Okay, but for example, I am getting this for the January month. Okay, I put a line here, it will come. See, for example, my charge is this much. How much I am going to collect? This will be a directly, it will give an indication here. That's what we are trying to explain here. Correlation can help the point to where there is a correlation. See, for example, I am taking this month. Okay, for example, till June, I put this graph. Okay, July, I just want to understand how much I am going to collect. I just need to know what is my charge amount. Okay, put a graph line and then connect with your payment. Then you know what is you are going to collect it from the graphical representation. That's what we are trying to explain here. Okay, the testing statistical difference mainly based on the p-value, we are going to collect this. Okay, and the linear regression is one method. I told you, right? The linear method will give you the indication whether we can collect it or not. Okay, the linear regression formula is y equal to a plus b0 plus b1 x bar. Okay, x is the input variable and b is the estimation of the regression analysis value, and b1 will be the intercept. Okay, so do you remember when you are doing a graphical analysis in the 10th or 12th standard? Okay, you will be asked to plot the graph, right? If you plot the graph based on the data, there will be an intersection will be there between y and the x-axis. There will be a slope will be available. That slope is called intercept. Okay, this also we can easily do with Minitab. I'll see that. Okay, I already put one graph. I'll try to show. Otherwise, I'll show it in the next class. Okay. So this linear regression is very easy to avoid this particular confusion, whether it is directly related or no correlation will be easily identified by this particular linear regression methodology. Okay, use the relationship between the two variable. Quantifiable and mathematical relationship between the two variable we can be identifiable by this particular linear regression. Here the B1 is a very important one, which is we call that as a p-value. The p-value should be lesser than 0.05. Okay, that will indicate you have a better relationship between these two data or not. Okay, and we will go to the main topic here. So so far what we covered is related to your statistical analysis. Here we discuss about, for this particular chapter, we discuss about multivariation in your input. Based on the input, how your output is going to affect. Okay, that we covered. And source of variation, how we can reduce your variation, that we covered here. So mainly this talk about your input variation has to be reduced, how we discuss in the CPOC, the same model. And here the variation in the Six Sigma level, there is a variation based on the position or cyclic or based on the temporal. And correlation and the correlation coefficient is very important. Correlation to understand, see for example, I am analyzing two data. For example, I am calculating my y, and I am thinking that x is going to affect my y. If there is a no relationship between this x and y, then my total calculation itself is going wrong, right? So before do any calculation, check what is the correlation. Okay, correlation is there, then you go ahead and then do this analysis. Otherwise it's a waste of time checking the incorrect inputs, right? That is the one thing. And this is a causation we discuss, and the p-value, what is the value of the p-value we discuss. And linear regression is a very important one, which will identify whether there is a relationship or not. Okay, that's the way. Okay, right. Now we are going for a root cause analysis and waste elimination. Any doubts so far?
No, sir.
No, right? The linear